All right, let's dive into something really cool today. We're going to talk about a design pattern, a super clever way of thinking that solved a massive problem decades ago. And the wild part is, its ideas are probably more important today than they've ever been. We're talking about the art of the pseudo conversation.
So let's just set the stage here. Imagine you're building an app, and not just for a few people, but for thousands, maybe tens of thousands of users all at once. Now, if your program had to stay running, holding onto memory and power for every single person while they're just, thinking or typing, your whole system would just fall over. So how on earth do you talk to everyone without just waiting around?
Here's how we're going to break it down. We'll start with the problem, what I'm calling the conversational conundrum. Then we'll look at the elegant solution, uncover the secret that makes it all possible, peek at some actual code, and then, this is the fun part, we'll see why this old idea is still a huge deal.
Okay, first up, the conversational conundrum. What is the big deal with a computer program just waiting for you?
Well, the most obvious way you'd think to write a program is what we call conversational. The program starts up, sends you a screen, and then it just sits there. It waits. But while it's waiting, it's holding onto memory. It might have files open. It's occupying a slot that another user could be using. It's basically tying up expensive resources just to twiddle its thumbs.
And you don't have to take my word for it. This quote from the old CICS documentation, that's a big-time mainframe transaction system, it just hits the nail on the head. The program spends most of its life waiting. Not computing, not working, just waiting on a human.
And this chart really puts it in perspective. It's kind of crazy when you see it laid out like this. For any given period, maybe 10% of the time the computer's actually doing something. The other 90%, that's you. That's the user thinking, typing, getting distracted, grabbing a coffee, whatever. For a system trying to serve thousands of people, this is just a total disaster.
So, okay, waiting is horribly inefficient. We get it. There has to be a better way to have a dialogue, right? Of course there is. And it's called the pseudo-conversational solution.
Now, this idea completely flips the script. Instead of one long, lazy program that waits around, you build your app as a series of tiny, super-fast transactions. Each one does one little job, like sending a screen or processing some data, and then, poof, it's gone. It completely vanishes, freeing up every single resource it was using. The system is only busy when there's actual work to do.
I love this analogy because it makes it all just click. A conversational program is like making a phone call and just keeping the line open, paying for every second of silence. It's wasteful. A pseudo-conversational program is like sending text messages. You send your text, you put your phone down, you go about your day. You only pick it up and use it again when you get a reply. It is so much more efficient.
So what does this little dance look like in practice? It's actually pretty simple. Step 1. A program runs, does its thing, and sends a screen to the user. Step 2. Right before it ends, it tells the system, hey, when the user finally hits enter, I need you to run this other program. Then it terminates. Step 3. While the user is thinking, the system is totally free to help other people. Step 4. The user hits enter. And finally, Step 5. The system wakes up, looks at its note, and starts the exact transaction it was told to. Brilliant.
Now this all sounds great, but it brings up one massive, glaring question, doesn't it? If the program disappears, how does it remember anything? Let's get into the secret sauce here.
Right? I mean, think about it. If program A sends you a form and then completely vanishes from existence, how does program B, which is a totally new program, know who you are or what you typed on the last screen? How does it maintain the state of the conversation? It seems impossible.
Well, the answer is that you don't keep the state on the server. You pass it along. The old school way was a thing called the COM area. Think of it like a little chunk of memory, about 32 kilobytes, that gets passed from one transaction to the next, like a baton in a relay race. The newer, much more flexible way is to use channels and containers, which basically lets you pack up a whole bunch of data of any size and give it a name. It's the modern recommended method for sure.
And the absolute linchpin of this entire architecture, the magic wand that makes it all work, is this one command, return transID. It is so powerful because it does two critical things at the exact same time. It ends the current program, releasing all its resources, and it tells the system what the ID of the next transaction is, all while handing off that precious state data in a comma area or a channel.
Okay, enough theory. It's one thing to talk about it, but it's another to see it. Let's take a quick look at how the logic actually works in the code.
So here we go. Program 1 is finished. It's displayed a screen, it's done its job. Now it executes this return command. You can see it's specifying the next transaction ID, TRN2, and it's passing along a data area called term storage in the comma area. It's like it's packing a briefcase with all the important info and then telling the front desk, give this to TRN2 when they show up.
Now, when the user hits enter, TRN2 starts up. It's a completely fresh program. It knows nothing. So what's the very first thing it does? It has to check if that briefcase was left for it. It looks at a special field the system provides called EIBCLN, which is just a fancy name for comma array length. If that length is greater than 0, boom, the program knows, aha, I'm picking up a conversation, and it can then unpack the data and get to work. It's that simple and so incredibly powerful.
So you might be thinking, okay, that's a neat history lesson about mainframes, but why does any of this still matter? Because these aren't just old ideas, these are the fundamental principles that make the modern digital world work. Let's connect the dots. This whole pseudo-conversational design is really built on 3 giant pillars that are crucial for modern software. First, statelessness. The server holds no memory of you between requests. Second, scalability. Because resources are freed up instantly, the system can handle a massive number of users. And third, efficiency. You're never ever wasting expensive computer time just waiting around. Statelessness, scalability, efficiency. Does that sound familiar? It absolutely should. This is the blueprint for the World Wide Web. When you click a link, your browser sends an HTTP request to a server. The server figures out what you want, sends the page back, and then it completely forgets you ever existed. Every single web interaction is a stateless pseudo-conversation. The very same ideas that made mainframes efficient are what allow billions of us to use the web today.
And that just leaves us with this one last thought, doesn't it? As we're all trying to build these huge, globally scaled applications and microservices, maybe the most important lessons aren't waiting for us in some new technology of the future. Maybe, just maybe, they're hidden in the elegant solutions of the past. Makes you wonder what else we've forgotten, right?